Welcome to all. See, recently or little earlier, I uploaded classes for analysis of singly and doubly reinforced rectangle sections by working stress method. Now, maybe I think total 11 parts were there. Now, new series. This is for design of shear reinforcement for beams. One of the most important. Remember, once again, by working stress method. As soon as I finish by working stress method, this one, immediately I will upload for limit state method. Practically, limit state method is more important. But remember, analysis of singly and doubly by working stress method and later by limit state method, concept or pattern is same, but values are different and also so many logics are different, but not for shear reinforcement. What way we proceed for by working stress method, it is 100% same for limit state method. Only some table number change and adding one extra called factored or ultimate. See, a term called V will come. Limit state, VU. Then little later a term called Vs will come here. VUS. Sigma SV will come here. 0.87 Fy. Therefore, it is identical. So, correctly go through by working test method. What happens is, unknowingly, you are studying for limit state. But again remember, I will upload for limit state. When I upload for limit state, you can see procedure sheet. See, today I am giving procedure. This procedure I written here. You can see same procedure. See, same pattern. You can see there also. Means, what I will do? I will take a photo of this one and seeing that photo, I write once again so that you can make out identical. Okay. Now, design of shear reinforcement for beams in the form of vertical stirrups by working stress method. Class means what all I explained so far. Okay. Now, data. What all you require? See, I won't waste time sketches all now. Width of beam, you should, if you want, you should write here. Those who are serious, write everything. Width or breadth of beam B. Effective depth D. AST provided, remember, for cross section considered. What is that cross section considered? I will tell when we go for numericals. Right now, see, when you design shear reinforcement, you have to consider a cross section. It may be anywhere. It may be somewhere inside the span or maybe at support, anywhere. So where you decide cross section or for which cross section shear force is V, that we are designing. So, and shear force across BD, AST provided and also shear force for cross section considered, that is called V. Limit state method, I will tell VU. I will add one thing, factored shear force. Okay, leave it. Now, procedure. First, 1 minute now, you understand the procedure thoroughly. I will do one thing. I will explain all the terms. 100% same for limit state method. One more thing. Sometimes people get confusion. See, a term called tau V, a term called tau C max, a term called tau C will come. Little mix up. Some will tell, sir, little confusion. To avoid confusion, see, I wrote up to here. Further not because I will give a practical example. As usual, some money matter. Some people will tell, he talks about money matter. He leaves technical part. For them, my reply. A person who teaches, his purpose is to see that everybody will understand it. Not to show how much he knows. If he teaches in such a level so that he will go only technically, and if people don't understand, his knowledge is wasted. Nobody will appreciate. They will tell high level. I will tell not high level, low level. If a person who teaches, he cannot convince the students. It is not called high level. It is called low level. Maybe he may be knowing subject. No, you should know what problem students has got. So, these money matter examples, I give everywhere. Whether people comment or not, I am not bothered. My purpose is that everybody will understand. Okay, start now. First find nominal shear stress for cross section. See, what all I tell, if you want to write later, this one you take a screenshot later, and what you do is, when I complete the procedure, take a screenshot and little boost it up, zoom it, and then seeing that one in a paper, neatly write entire procedure. Refer it for further numericals. Okay. Shear force V, there will be shear stress. Now, how is the distribution of shear stress? That all I won't discuss here, because in the regular group I discussed it. For them I give extra information about behavior. Now here, procedure to design shear reinforcement, that's all you are covering. Right now I am doing with vertical stirrups. Okay. Find nominal shear stress for cross section, tau V equal to V by BD. 1 minute. This word nominal is used by IS code. First of all, I have objection. The word nominal shear stress means what happens? See, in English, nominal, what do you call? Namesake. Just a namesake, not much important. So wrong. IS code, I don't agree with them. Okay. They use the word nominal. They should have given only shear stress or some average shear stress, etc. Okay, no problem. So you do not consider the word, this nominal, you just do not consider it. Leave it. You use the word because IS code giver. So find shear stress for cross section, tau V equal to force by area V by BD. Okay. Now, note, IS code I told you, they use the word nominal. Don't think that way. Tau V is shear stress due to shear force V. That is, what shear force is acting for the cross section, the stress due to that one. Therefore, cross section should be able to resist it. So tau V is very, very important. Cross section should be able to resist it. Now, right now I will go there, give money matter example. See, later I will rub it out. You want to buy something, anything, buy, say a car. Cost we don't know. Tau V is the cost. Tau V is the cost, because why? Whatever is the cost of the car, you have to pay it. Here, whatever shear stress will come, cross section should be able to resist it. So because this tau V is due to shear force V, tau V is the cost. I don't know how much is the cost. We will discuss later. Okay, leave it now. Now, we got tau V. Refer to IS code, table number 24. Page number I will not tell. Get tau C max. A term called tau C max will come. Red color. Why? Danger number it is for this one. Tau C max. What is tau C max? I will tell it later. Now, see here. Tau C max is, you go to table number 24, based on the concrete grade, you get tau C max. Tau C max is maximum limit for tau V, or IS code told maximum limit for tau V, like maximum limit for speed is 80 kmph, means you should not drive at a speed more than 80 kmph, that way. Even with the shear reinforcement, see, it is even with the shear reinforcement, that is even after providing shear reinforcement. So, see, whether you provide shear reinforcement or not, IS code right now not bothered. How much you are providing, not bothered. But even after providing shear reinforcement, you should see that tau V should not exceed tau C maximum. Okay. Therefore, tau V should not be more than tau C maximum for safety. For safety or adequacy of the cross section. You write. For safety or adequacy of the cross section, or for selected cross section to be okay. Okay, now you got tau V. Compare tau V with the I will go to money matter later. Compare tau V with the tau C maximum. If tau V exceeds tau C maximum, see, just now I told, tau v should never exceed tau c maximum. In case your tau v exceeds tau c maximum, cross section should be redesigned. You can write extra, provided cross section is not okay, it is not adequate, therefore, or you can tell not safe. Or if you go to ETAP software, for that member, instead of numbers for shear steel, you won't get number. Red color, you get O by S. I think those who know software, O by S. What is O by S? ETAP title, danger number. Whenever O by S comes, it means you should redesign it. It is not safe. Over shear. Okay. Now, over. So therefore, compare tau v with tau c maximum. Tau v, if compare tau v, suppose your tau v exceeds tau c maximum, cross section should be redesigned. No, continue. Okay. Now do one thing. But in case you get tau v equal or less than or equal also will do. See, when the speed limit is 80, if you go at 80, no problem. 81 you cannot go. Tau c maximum, proceed further. Proceed further. Okay. Proceed further means here. Here. 1 minute. One note. Comparing tau v with the tau c maximum is only a check for safety or to decide whether cross section provided is okay or not. Very important. Sometime I will ask in the class, suppose tau v is less than tau c maximum. Okay, sir, safe. Shear reinforcement required? Not required, sir. No. Whether, okay or not. We have to ensure tau v not more than tau c maximum. Now, important, this comparison of tau v with the tau c max will not decide, this is only safety check, will not decide whether shear reinforcement is required or not. Note continued, whether shear, new sentence, see, full stop or not, full stop here, okay, then new sentence, so capital W. Whether shear reinforcement is required or not, that will be decided later, only after we compare tau v with tau c. So, tau c is coming up, still not right here. Tau c is a new term, which will come, see, you see here, somewhere here. Get tau c, little later. You write here, tau c will come little later. It will come later. Okay. So, whether you require shear reinforcement or not will be decided only after you compare tau v with tau c. But when you come to this step, your tau v should not exceed tau c maximum. Okay. Now, procedure continued. That is when tau v is less than or equal to tau c maximum. Means, that is, cross section is okay. Still we don't know tau c. See, this, when you got tau v not more than tau c maximum, cross section is okay, but whether shear reinforcement is required or not required is still not decided. It will come later when you get tau c. Okay, now, get tau c. What is tau c? Permissible shear stress in concrete without shear reinforcement. Without any shear reinforcement. No shear reinforcement. Only concrete. You should write here. So, tau c is permissible shear stress in concrete without shear reinforcement. Class means you can write here. That is, you should write how much shear stress concrete alone can resist without any help from shear reinforcement. I will come to money matter now. To get tau c, what to do? Let me come up to here. Then I will give money matter. To get tau c, first find percentage of tension reinforcement provided for the cross section. Cross section considered. That is PT provided. See, PT provided is area of steel provided by BD, D means effective depth, into 100. But usually that is AST by BD into 100. But popularly it is called not 100 AST by BD. I don't know why. See, AST by BD into 100 you have to tell, into all you require. So people decided IS code, why that much struggle? 100 AST by BD. Get 100 AST by BD. Then go to table number 27. IS code. Get the value of tau c. How I will tell you when I go to there's a table there where tau c values are given based on PT. You can write tau c values are given based on PT for different grades of concrete. Okay. PLIFIV. Remember, don't write that way. Perform linear interpolation for intermediate values. See, IS code has given for 0.25, 0.5, 0.75, 1, etc. Suppose you get 0.63. What do you do? See how much for 0.5, how much for 0.75, interpolate linearly. Okay. Now, compare tau v with tau c. Make a note here. One note you make here. Finally, you should write, I will dictate. Time has come to decide whether shear reinforcement is required or not. Because see, I told earlier, whether shear reinforcement is required or not will be decided little later only when we compare tau v with tau c. So compare tau v with tau c. Okay. Now, time being, leave it. I will go to money matter. See, I told you, you want to buy a car, car cost is tau v. That is, this is the car cost due to shear force, tau v. So, when the cost is tau v, what? You have to pay it. You have to pay this. I will tell you, what is tau c, I will tell. Tau c is here. How much shear stress, somewhere I wrote here, how much shear stress concrete alone can resist. Remember, you are concrete. So tau c is what? How much money you yourself got. That is your own money. Your own money. Just imagine that money is 2 lakhs. 2 lakhs. Just imagine. So, without any help, you see, tau c means how much stress concrete alone can resist. How much purchase you can make without anybody's help. Remember, you are concrete. 2 lakhs rupees. Rupee or dollar, anything. 2 lakhs. Now, tau c max comes. See, be careful. Tau c max comes. In case you see here, suppose the shear stress concrete alone cannot resist, what we will do? We will provide shear reinforcement. So now there is a friend. Your friend is there. Your friend is, see, remember, your friend is not tau c maximum. Friend is shear reinforcement. Shear reinforcement. How much money he will give? Remember, your friend has got 8 lakhs with him. 8 lakhs. So he told you, see, in case you require any, suppose you want to buy a car, suppose you got a problem, if you want funds, he told, I can give maximum up to 8 lakhs. So 8 lakh is not tau c maximum. So remember, 8 lakh is not tau c maximum. He told, I have got 8 lakhs with you. You got 2 lakhs. Okay, now, how much is tau c max? I lost in the class. If you take a money matter example, now you can tell your tau c max is 10 lakh. Why 10 lakh? 10 lakh because you have got 2 lakhs with you. Your friend told, if required, I can give up to 8 lakhs. Beyond that, he told, I cannot give. That's all. Maximum. But he will not give 8 lakhs. He will give whatever you require. Suppose you require 3 lakhs, he will give only 3 lakhs. If you ask him 9 lakh, what he will tell? Sorry boss, I have only 8 lakhs. So beyond 8 lakhs, I cannot give. So here see, tau c max is maximum limit for tau v even with the shear reinforcement. Even after taking help from your friend, How much you can buy? 2 lakh you have got. He will give 8 lakhs. So your tau C max will become 10 lakh. See, because tau C max is what? How much shear stress allowed even with shear reinforcement. Suppose you take the help of shear reinforcement, then limit 10 lakh. Okay, now I will tell case 1 here. See, here, no space here. Case 1. Okay, these are all over now. Okay, I go to first money matter will complete. Case 1. You have, okay, I will remove this one now. Case 1. You need, first of all remember, before that one. Now, tau C max is 10 lakhs. Now, make a note. Suppose you want to buy a car costing 15 lakhs. No, outrightly not possible. Why? The cost of the car, tau V, exceeds 10 lakhs. You got 2 lakhs with you. Your friend is willing to help 8 lakhs. So even after taking help of 8 lakhs from your friend, you cannot buy more than 10 lakhs. So if the cost of the car is more than 10 lakhs, it is not possible to buy. Here, see, you won't come here. Cross section to be redesigned. You have to do some other planning. Something else you have to do. This arrangement will not work out. Okay, hope it is clear. Now, I told compare tau V with tau C. Now important. So right here, when we compare tau V with tau C, it is understood that tau V is section is already safe, means the tau V is not more than tau C maximum. So tau V is not, that is, you are not buying a car more than 10 lakhs. Okay, understood. Case 1. Case 1. That is tau V less than or equal to tau C. For example, you want to buy a car for 1.5 lakh. 1.5 lakh. Second hand car. Okay. You yourself has got 2 lakhs. 2 lakhs. So you want to buy a car which costs less than the money, how much you have got? In the class I will ask. Is the help required? No, sir. Why? Sir, you already got 2 lakhs. No. Friend is not required. Friend not required means help from friend is not required. So, if your tau V comes less than or equal tau C, shear reinforcement is not required to be designed. But in the RCC, even then, you have to provide nominal shear reinforcement. I will tell you later. Okay. Case 2. Tau V is more than tau C. For example, you want to buy a car of 8 lakhs. 8 lakhs. I will ask, okay, sir. Not 8 lakhs. See, 7 lakhs. 7 lakhs. I will ask the students, can I buy more than 10 lakh? No, sir. Why? Because yours 2 lakh, friend 8 lakh, total beyond 10 you cannot go. Beyond 10 you cannot go. Okay. If it is beyond 10, you won't come here. No. I want to buy a car for 7 lakhs. Yes, sir. Help required? Yes. How much? They will tell, sir, 5 lakhs. Why? Money matter. You want to buy a car of 10 lakhs. You yourself has got what? 2 lakhs. So, you require help of 5 lakh from your friend. Who will give it because he got 8 lakhs? So, therefore, hope this concept clear. Further, I can't waste time. You go through the example again. Because it is money matter, it will be very crystal clear. There will be no confusion. As usual, same problem. Here. Now, I will remove all this now. I will go technical part now. Okay. I will compare tau V with tau C. Now do one thing. We will talk technically. Case 1. Case 1. Tau V less than or equal to tau C. Case 1. Tau V less than or equal to tau C. Now, conclusion. Therefore, shear reinforcement. See, today, because of space problem, little smaller I wrote. You should zoom in the laptop or you see in the laptop and write. RI means reinforcement, because if I write everywhere reinforcement, space, it will consume space. So remember, when I write RI, you should write reinforcement. Shear reinforcement is not required. not required to be designed. To be designed. Or now talk, see, 10 was not correct. Tau v less than or equal to tau c. Or go to logic. Shear stress to be resisted is less than how much concrete alone can resist. How much stress comes here? Concrete capacity is more than that one. So shear reinforcement is not required to be designed. Then, required design. Even then, provide nominal shear reinforcement or provide minimum shear reinforcement. Minimum shear reinforcement. What about spacing? It is a stirrup. You don't waste money. So provide how much maximum possible. So at what spacing? At maximum permissible spacing. At maximum permissible spacing as per IS code. This will come little later. See, little later I will write this one. Once I finish everything, then I will write what is that maximum spacing. You write here. Provide nominal or minimum shear reinforcement at what spacing? Maximum permissible spacing. How much? He will write little later. But you do one thing. You write, when I finish the class, I will write somewhere here, that one. You would write that here once again if you want. Okay, over. So this is a case when shear reinforcement is not required. Now the most important, when shear reinforcement is required. So some space required for me. Just a minute. Okay, I will go here because later I may have to take a photo. Sometimes I myself become problem for taking photo. Okay, I'll remember. Then I have to adjust my own, this one. Okay, this all I will remove now. I will continue. Or I'll do one thing. I will clean the board slightly because it does not look nice. Just a minute. I will continue. I already told this all you are right. I wrote because of time problem. I got a class now. Case 1 already over. Tau v less than or equal tau c. Shear reinforcement is not required to be designed. I told provide nominal or minimum shear reinforcement referring to IS code. See, it is coming here. Anyway, later when you see example, everything will be clear. I will talk further slowly. Now, come to case 2. Remember, 99% of the case practically comes to case 2. Very rarely for beams, etc. No. See, important beams, small beams where load is very less or minor importance, it may not happen. All major beams, your tau v will come more than tau c. So case 2, tau v more than tau c. Imagine you want to buy a car for, I forgot now, same example I will tell everywhere now. In next time onwards, remember your own money 2 lakhs, friend can give you 8 lakhs. So you cannot purchase more than 10 lakhs. Case 1, tau v less than tau c. You want to buy for 1.5 lakhs, help not required. Case 2, you want to buy for 7 lakhs. If you want to buy for 7 lakhs, 5 lakh help required from your friend. I will remember it. Okay, now, maybe you want to buy a car for 7 lakhs, you have got only 2 lakhs with you, so you require help from the friend. How much help you require? Only 5 lakhs. He can give because he got 8 lakhs. Okay, now, shear reinforcement is case 2, tau v more than tau c. Shear reinforcement is required to be designed. Note, right now in this series, we are considering shear reinforcement in the form of vertical stirrups. Important. Second round will be there when cranked bars are used. Let us finish this first. Okay, now, see this way. See, some top bars are there. How many bars you are not bothered? Bottom bars are there. This is the stirrup. This everybody knows. This is called spacing. I need not explain. People going in the road everywhere, they will see this one. Okay, now, First you decide diameter and number of legs for vertical stirrups. Right here, I will dictate. The most popular in India right now for normal case is 2-legged 8-tor. If I ask in the class, 2-legged 8-tor, what is ASV? Student will tell you within no time, sir, 100.53. Okay, you know it later. Then we have to find the spacing SV. Remember, spacing SV based on strength. You should think a little. If the spacing becomes more, it becomes what? Lesser capacity. Beam will be stronger in shear strength will be more when the stirrups comes closer. Therefore, what spacing you get now based on strength, later you should not provide more than that one. Common sense. See, suppose you provide a spacing more, it becomes weaker. You make it lesser, let the bar come closer, stronger. Okay. For vertical stirrups, as per IS code, spacing SV is sigma SV ASV D by VS. Actually, IS code told VS equal to sigma SV ASV D by SV. I am interchanging. See IS code. Okay. Page number you search. It is there where table 23 and 24 are there. Somewhere it is there. Sigma SV is the permissible tensile stress in shear reinforcement. But remember, IS code told sigma SV is nothing but sigma ST. By this time, you know what is sigma ST. Okay. But there is a condition. IS code told one more thing. At any cost, sigma SV value should not be taken more than 230 Newton per mm square. Reason I told in the class for you procedure. So sigma SV equal to sigma ST, but you should not take sigma SV more than 230. When I do numerical, I will take FV 500 steel for which sigma ST is 275. Still you will take 230. Okay. Now, ASV is cross-sectional area of legs of the stirrups. Is very simple. Two stirrups are 2 legs. How many legs we don't know. What is the cross-sectional area? Equal to pi by 4 of diameter square into number of legs. For 2-legged 8-tor, it is a popular number 100.53 mm square. Leave it. VS is shear force to be resisted by vertical stirrups. Remember, from stress language, you are going to force language now. VS is the shear force to be resisted by stirrups. VS equal to V minus VC. How much is the shear force? Subtract how much shear force concrete alone can resist. See, concrete alone can resist a stress of tau c. The stress you have to convert to force now. Okay, done. Where VC is shear strength of concrete without shear reinforcement, or maximum shear force concrete alone can resist without shear reinforcement. How much? VC equal to stress into area. Stress is tau c, area is BD, tau c BD. Actually, therefore, substitute tau c is already known to you. Substitute, get VC, V minus VC, get VS. Note, this side, this VC, I only introduced for understanding. IS code simplified it. They simply told what? Vs equal to V minus tau c BD. Suppose I write that here, Vs equal to V minus tau c BD. I don't have to explain. Why? Formula. No. I want to explain and make you understand what is the tau c BD. So I wrote. So substitute tau c here, get Vc, V minus Vc, you get Vs. No, once you get Vs, substitute in this equation, everything is known. Get the spacing SV. Note, this is spacing based on strength. Very, very important. No. Therefore, later, see, no space here, something I wrote, I will dictate. Later, at any cost, you should never provide spacing less than above value. I will tell that way in the class. Students will agree. Yes, sir. I will tell what? Yes, sir. I told you should not provide spacing less than this value. Means you give more. No, sir. You should not exceed the limit. Then do one thing. Danger. when you tell and write something, understand it. Later, this deliberately I wrote, later, at any cost, you should not provide spacing, what? More than above value, not less than, more than. Why? If you provide more spacing, it becomes weaker. You provide, suppose the spacing comes to, for example, 118.5 mm. You make it 125. Oh, beam becomes weaker. Why? Tit-ups are going away. You make it 100. Good. Tit-ups comes closer. So, later, at any cost, you should not provide spacing, what? More than this value. I first wrote less only to make you understand. But in some offline class, some student will tell, sir, less than. I will tell, keep quiet, don't tell. I will come to that later. It is, he knows that I am not getting confused. Just to trap I am writing. Okay, now, once you get that one, now refer IS code. Because right here, whatever spacing you get here, IS code has something else to tell. IS code will give you what is the maximum limit for the spacing. The concept of all these I will tell when I take numerical. Okay. As per refer to IS code and get maximum permissible spacing for vertical tit-ups. As per IS code, maximum permissible spacing for vertical tit-ups is 1, 300 millimeter. Any order. Second one, 0.75 times effective depth. The reason for 0.75D diagonal tension crack, I thoroughly told in the regular batch. They know it. They also know how tit-up works in shear. When you provide tit-ups, how it actually resists shear, I told them. Okay, now, there is one more provision. Remember, the last provision is not always applicable. The IS code told some language, search IS code, not this page, some other page. You can see in the IS code, minimum shear reinforcement. See there, they interchange it. If you again interchange, the spacing will become ASV into 0.87 FY divided by 0.4B. But remember, they told these two are compulsory. This they told for structures of minor importance, like lintels, not all lintels, or when the shear stress is less than tau c, means very, very small shear stress. They told this provision need not be considered. They told need not be considered. Means you can consider, if you consider no harm, they told you need not consider. So anyway, no problem. They did not tell should not be considered. Need not be considered. Okay, leave it now. Here, one condition, as per IS code, here, Fy is not to be taken more than 415 Newton per mm square. Okay. Now, last step. See, there is no place here. I will write here now, concluding part. Okay, this all I will continue. Last step. Continued. Make a fair copy. Consider all three values and decide maximum permissible spacing as per IS code. Which one? Remember, among these three, whichever is least. When I do numerical, I will tell why least, over. Then finally provide or decide spacing for vertical tit-ups. Remember how one IS code limit, next one design spacing. For that, what to do? Compare spacing SV based on design, based on strength basis. That is this value. I will write tick mark here. That value and maximum permissible spacing as per IS code. That is this value. Right here. Consider or provide whichever is lesser. Whichever is lesser. And remember, note right here, when you are rounding up, round up lesser side, not higher side. Round, if you are, see, fraction will come. Finally, imagine, answer is 127.9. Don't take 125. Round up lesser side, 120 or 100. People will take 100 only. Okay. That is the procedure. Now, correctly go through the procedure, make full fair copy, be ready for example coming up in next class. That is part 2. This is part 1 for design of shear reinforcement by working test method. When you go to limit state method, this much I will not explain. And remember, throughout this course, when the money matter comes, I'll write somewhere here, I'll forget. 2 lakhs you have your own money, 8 lakhs friend will give. Case 1 is what? If you want to buy a car more than 10 lakhs, you can't do anything. One case is what? You want to buy a car for 1.5 lakhs. Help is not required. Second case, 7 lakh you want to buy. Yes. Then help required for 5 lakhs. Sufficient. I will use it everywhere now onwards. Okay. Time over. Thank you.